So, data analysis is a very important part of research. Without analyzing the data, you cannot complete your research. That's why data analysis is a major part of a research. So, first of all, we just check out the research process. In research process, first of all, we identify the research problem. What is the problem that we identify? After that, related to that problem, we review some literatures, means some research papers, some review articles related to that problem. After that, we formulate hypothesis and objectives, means suppose we select one problem in that part, what we want to do, okay, that we mention in objective and hypothesis. Now next part is uh, designing methodology, means in that research, what are the techniques that we want to use. That's a part comes under the designing the research methodology. After that, next part is the data collection and then data analysis. So data analysis is a very crucial part of research. Why this data analysis is important in a research? See, when you want to some predict some result, when we want to some forecast, when we want to do planning, when we want to some do some optimization. In that cases, we need data, and we need some techniques that give some information about that data. So that's why data analysis is a very crucial part in our research. Now next is, but data analysis is incomplete without statistics, because if we know the statistics, then and then only we do the data analysis. Okay, so first of all, in this in this session, we see what is the statistics, what is some basic definition of statistics. After that after that we see some scales, that means some type of data, we may say type of data. After that, some test and some models that we use in our data analysis. Okay, so first of all, statistics. Statistics is the what? Statistics is nothing but the branch of mathematics which involves the collection, organization, analysis and interpretation of the data. Okay, means first of all, what we do, I will explain one by one. First of all, we identify our research problem. After that, we we choose, either we want to choose the primary data, either we want to say choose secondary data. What is the primary data? What is the secondary data? The data that we collect from questionnaire, means after identifying problem, we formulate some questionnaire on the basis of that problem, on the basis of our objectives. So now here, first of all, we collect some that information from some peoples or some our samples that present in our research area. So we collect information from them. That's the primary data, and secondary data is available on websites and different platforms of governments also. Now second step is organization. We collect, first after collecting data, the data is a very present in a very raw form. Okay, so after that, what we do, we organize data, or sometimes in statistics we call as a tabulation. We do the tabulation, means after collecting data, we organize data in a very proper manner. Means ki ma'am, is it okay talk little bit in Marathi?
Nine, it's okay.
Okay,
It's
so
okay, sir.
okay, okay. So आपण काय करतो की डेटा एका स्पेसिफिक टेबल फॉर्म मध्ये म्हणूयात की किंवा एका स्ट्रक्चर फॉर्म मध्ये आणायचा प्रयत्न करतो इन ऑर्गनायझेशन ऑर वी मे से इन अ टॅब्युलेशन. नाउ नेक्स्ट स्टेप इज द अनालिसिस. On after organizing data or after done the tabulation, what we do, we the analyze the data. How we analyze the data? We use some techniques. There are so many techniques in statistics, like different types of testing, regression analysis, and we discuss that techniques further in further part of PPT. But the techniques are some statistical tools. We use statistical tools to analyze that data, and after analyzing that data we get some results. Okay, but that result present in a statistical language. In a statistical language, that means ki if just statistician know that result, but we calculated that result for the society. That's why we interpret that result in a very simple form, everyone understand that result. And finally, because see, if we interpret the result, but if you draw some diagrams of that result, or you draw some charts of that result, then it's easily then it's easy task to व्हॉट इज म्हणजे काय इन्फॉर्मेशन दिली आहे ते आपल्याला आयडेंटिफाय करण्यासाठी इझी जाईल. त्याच्यामुळे प्रेझेंटेशन, इन अ प्रेझेंटेशन we do we draw different types of graphs, like bar graph, pie chart, histogram, and many more. Now next is some basic concept of statistics. First is the population. What is the population? See, the meaning of population in general is different, but in statistic the meaning of population is different. Now suppose I want to study related to some factor that related to only big districts. Okay, so the number of peoples are living in a big districts, that's my population. Okay, suppose I want to do some research related to a big city only, so the number of peoples that lives in big city, that's my population. So number of samples, number of observation present in our research or our study area, that is nothing but the population. Sample is what? Again, sample is a very fraction part. Means see, if population is a large, means there is 1 lakh, 2 lakh, or more than that. So if population is large, it's not possible to cover all population. Why? Because we require some manpower, we require some time, we require some efforts also. Okay, but it's possible, but it requires some efforts, some extra efforts. Okay, but what we do not study the population, we study the sample. Okay, and sample is nothing but what? It's a fraction part of a population, or we may say subplot of a population. Means suppose there are 10,000 peoples, or there 10,000 observations present in my population. So I'll take just 100 samples by using some sampling techniques, by some sampling formulas, and I just use 100 samples. So that's part on that 100 sample, it's a part of that population. Means what? Ki sample is nothing but fraction part of that population that okay, that we studied. Okay, now next third definition is the statistical inference. So again, inference in in so called Marathi we call आपण अंदाज म्हणू शकतो त्याला. So inferential statistics, that's a very important concept in statistics. See, again, we not calculate the result from entire population. So what we do, we take a sample from that population. Okay, but that sample exactly represent our population. There are some techniques, or there are some tools that we use in a statistics. So we just check out ki these given samples are representing our population or not. So if that sample represent our population, then our inference is good inference. Okay, so that's why inferential statistics, what in inferential statistics we use sample to represent some population characteristics. Means like in a daily example, suppose we purchase one bike, and that bike gives average of 50 kilometer per liter. So we discuss with some person and we say that my bike gives 50 kilometer per liter average. So that means we, like, suppose we consider one example, suppose I consider one example, like suppose some Honda bike gives 50 kilometer per liter average. So means we make an inference from some observation, and we make a statement about population. म्हणजे आपण पूर्ण पॉप्युलेशन विषयी काय केलं की स्टेटमेंट दिलं की सगळ्या होंडाच्या त्या जी पर्टिक्युलर हे मॉडेल असेल त्याचं ऍव्हरेज 50 किलोमीटर पर लिटर असेल. सो दिस इज फ्रॉम सॅम्पल वी मेक अ इन्फरन्स अबाउट पॉप्युलेशन. दॅट्स नथिंग बट द इन्फरन्शियल स्टॅटिस्टिक्स. Now next is a type of data. In statistics there are mainly two type of a data. First is qualitative data, another is quantitative data. Okay, so qualitative data again contain two types. One is nominal data, second one is the ordinal data. Okay, so nominal data is like is data now not have some specific ranking or order. Means like gender of person, eyes, different types of fruits, or different types of colors. These things not have some specific ranking or not some specific order. Okay, so this type of data comes under the nominal data. Now next is the ordinal data. Ordinal data is involve some specific orders or ranking, like many times suppose sometimes we collect the questionnaire. That times what we do, we just like you sorry, I'll give one more next I'll give uh, another example. Education levels in our teaching, sorry, in education levels we start from nursery or elementary. Now after uh, high school, after that UG, after that PG. Means these steps have some specific order or ranking in examination. Okay, these things also have some specific order, one number, two number, three number. Okay, so this kind of a data comes under ordinal data. Now next is quantitative data. Again, quantitative data is present in the two form. One is the discrete data, another is the continuous data. In discrete data, uh, if we have a whole numbers, that time that data we called as discrete data, like number of employees in a company, like a number of students present in a class. Okay, this types of a data is nothing but a discrete data. Now continuous data is nothing but height of person, weight of person, that data present in the form of decimals, that data we called as a continuous data. These are few types of a data. Now next part is a measure of central tendency. Measure of central tendency is nothing but the statistical measures that indicate average value of our data set. There are so many types of measure of central tendency, but here we discuss about three types. One is mean, median, and mode. So mean is nothing but arithmetic mean. There are also two types of mean: geometrical mean and harmonic mean. But due to time, I just take one. That's the arithmetic mean or general mean, or आपण त्यालाच average म्हणतो. So arithmetic is nothing but what we do in arithmetic mean, we try to find center value of our data. Okay, so for that, in arithmetic mean, what we do, we just we calculate the sum of all data and divided by total number of samples that we have. Okay, so see here one example. In this example here, total 5 samples, just take a sum and divide by 5, so we get the mean. Now median is nothing but the middle value of our data. That value divides our data into two equal parts. So that value is nothing but the median. And uh, next step is the mode. Mode is nothing but the most frequently value in our data set. Means see this below data, here 20 occurs 2 times, so that's why here median is 20. Sorry, here mode is 20. So now the question arises, if there is a mean is sufficient, then why we require median, mode to measuring the central tendency of data? See, whenever there are again in statistics there are different shapes of data is present, and means generally there are different shapes of data. If we draw the histogram, then we find that shapes. uh, so whenever we have skew data it like means ki, suppose we have 100 observations, suppose we are conducting one examination, and in that examination we have 100 students, okay, and marking level is between 0 to 100, okay. So near about 80% students get in between 0 to 30, in between marks in between 0 to 30, and some 20% student get marks in between 30 to 100, okay. So this type of values म्हणजे हे काय रिप्रेझेंट करेल की 0 to 30 मध्ये जास्त फ्रिक्वेन्सी रिप्रेझेंट करेल, ओके. सो मग त्याच्यामुळे हे नॉर्मल येऊ शकत नाही. मग त्याच्यामुळे ह्याला आपण स्क्यूड म्हणतो की तो एका साईडला झालाय, एका साईडला जास्त व्हॅल्यू आला तो स्क्यूड. तसं आणखीन दुसरं प्रकार येऊ शकतं की 70 ते 100 मध्ये जास्त व्हॅल्यू होतील, जेच 0 to 70 मध्ये तितक्या 20% आणि 70 to 100 मध्ये 80% अशा व्हॅल्यू आल्या. तर याच्यामध्ये काय झालं की मॅक्सिमम डेटा हा 100 कड टिल झालाय. मग त्याच्यामुळे पण त्याला आपण हिस्टोग्राम त्याचा प्लॉट केला तर तो काय येईल की एका साईडला जास्त फ्रिक्वेन्सी दाखवेल. सो अशा प्रकारच्या डेटाला आपण स्क्यू डेटा म्हणतो. आणि जेव्हा आपण स्क्यू डेटा असतो आपल्याकडे, तर तेव्हा तिथे मीन ही टेक्निक आपण यूज करू शकत नाही. का? कारण की मीन त्या डेटाचं सेंटर व्हॅल्यू रिप्रेझेंट करू शकत नाही. त्याच्यामुळे तिथे आपण मीन यूज करू शकत नाही. त्याच्यामुळे तिथे आपल्याला मीडियन यूज करायला लागते, कारण की मीडियन आपली डेटाला 2 इक्वल पार्ट मध्ये डिवाइड करते. नाउ नेक्स्ट इज मोड. आय विल गिव्ह वन अनदर एक्झाम्पल फॉर मोड. सी, whenever suppose there is one shopkeeper, and that shopkeeper sells shoes, and generally uh, 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 the shoe size is not present in the form of like 8.5, 8.3, okay. So if a shopkeeper wants ki which shoe size averagely sell maximum in a month, so what shopkeeper do? Shopkeeper note down all shoe sizes and take a mean of that, and they find ki the mean comes like 8.2, but 8.2 is not available size of shoes. So in that type of examples we require the mode. Means what number of shoes people purchase more, okay. So in that type of example we require mode. So mode is calculate maximum frequently value. Means suppose 8 number shoes purchase maximum, 8 number shoes people purchase maximum time, or 9 number of shoes people purchase maximum time, then mode is 9, okay. So center of that data is 9. So another example is suppose we want to calculate the average number of peoples in family of particular city, and we take just arithmetic mean and calculate that how many average people lives in a family. So our answer come is like 3.9 or 3.8. So there are no 3.8 people available now. So that's why in this type of cases we use mode to represent the center value of our data. Now next is a measure of central tendency. It's a measure the center values of our data. Now another concept is a measure of dispersion, okay. So measure of central tendency measure the center value, but measure of dispersion measure the spread from the our mean or from our central tendency. Means how many values are separated from our, or how how many values are spread from our center value, like our mean or our median. Okay, so if you want to find how many value of value spread from our mean, so that time we use measure of diffraction to calculate that thing. Now see, here is a some here is four type. There are so many types of measure of central tendency, but we discuss these four types. First is range. A range is what is a very simple measure of central tendency. Is a simple of simplest measure of dispersion. So in a range, what we do, we just take the maximum value in our data set, and just we take the minimum value in our data set, and we take the difference between maximum value and minimum value. So see here in this example, here is the maximum value is 30, and here is the minimum value is here is a here is minimum value is 10. So difference between 30 and 10. Okay, so is nothing but 20. So here range is 20. Now second is variance. So variance is nothing but what? Variance is average square deviation from its mean. Average square deviation from its mean. See, this is x bar is the average. Okay, it's a mean, it's the arithmetic mean, and this x's are some values. So distance from this exercise from its mean is either present in the form of negative values or is either present in the form of positive values. If you draw, if you draw this values on some sheet, so we find key some distance are positives and some distance are negative. So that's why we take a square. Okay, and that's why we take a square, and after take a summation of all these things and divided by total number of observation minus 1. So whenever we want to calculate the sample variance, then that time we divided by n minus 1, and whenever we want to calculate the population variance, that time we divide by total number of observations, that's a n. Okay, this is the difference between sample variance and population variance. So here I mentioned sample variance, so that's why I take n minus 1, and this quantity represent the spread. Okay, so here answer is 50. Okay, so this quantity represent the spread. Okay, maximum the spread, minimum the accuracy, or minimum if variability is maximum. So whatever we choose, or what means whatever we want to study, if that thing shows maximum variability, means that thing or that type of data is not good. Now next is, again there are again two types of measure of dispersions. So we just take the under square root of mean deviation, square root of variance, so that we call the standard deviation. So previously we calculated variance, and in that case our variance is 50. So after taking square root of that variance, that's a value come 0.707. That's a standard deviation. Means if you take root of variance, that value represent the standard deviation. Now next is interquartile range. That's the IQR. IQR is nothing but it's measure the spread of 50% data, and is denoted by using Q3 minus Q1. Here Q3, Q1, these are the quartiles. Quartiles means what? Q1 is the first quartiles, means that indicate 25% value of our data. Q2 is the second quartile, that indicate 50% value of our data. Q3 is the third quartile, that indicates 75% of value of our data, and maximum value, that's means 100% value of our data. So that's the maximum. And okay, so here Q3 minus Q1, it's an interquartile range, and here see in above example, if you take the Q3 minus Q1, then it comes 10. So interquartile range of our data is 10. So why we calculate this measure of dispersions? Because measure of dispersions are very important. I'll give one example. in cricket match there are two players, and they score uh, 300 runs in 5 matches, and player A score consistently 60, 40, 50, 60, 90 like this, and player B scored 100, 150, 10, 40 and 0. Okay, so suppose uh, we want to predict which player perform better in next match. So our obvious answer is A. Why? Because there is the spread of runs of A is very less than the B. See, average is the same. If 300 divided by 5, average is the 60. Both players have an average 60, but if they have an average 60, but we choose A. Why? Because the spread present in your data. Because some uh, the player A score consistent, scores are consistent, but player B score are not consistent. So that's why we choose player A, because have a minimum variance. So when we have a minimum measure of dispersion, that means ki whatever we take or whatever we calculate some quantity that related to data, that's a better. This is the application of measure of dispersion. Now next part is the hypothesis testing. After See, this is a very important part, because in every research and every uh, in everything in statistics means we want to use some test, we want to fit some model, there is some hypothesis. Hypothesis is like it's a pre-assumption of our problems. What are the possibilities? So hypothesis predict the possibility of our problems. I'll just take I'll give one example. See, here is one example. Suppose one company claims that uh, uh, they claim that they resolve customer complaint within a 20 minutes. Okay, so in this case, what are the possibilities? The first possibility is what? Our company solves, that particular company resolve customer complaint in 20 minutes. Okay, and what is the alternative things? Either they resolve complaint very faster than 20 minutes, or means in 5 minutes and 10 minutes, or they resolve that complaint take more than 20 minutes, like uh, 35, 40 minutes. So one thing in statistics, the clear difference in statistics and mathematics is, you see, in a mathematics, suppose 20, we said 20, 19 are different things. Okay, 19 is a different, 20 is a different. But in statistics, because we deal with samples, so we cannot say if some 20s and 90 are significantly differ. Okay, so that means we require to test if they are significantly differs on the basis of their central tendencies and on the basis of their dispersions. Okay, so in this problem, what we do first, what some researchers do first, they collect some samples, those have some complaint, and they given to that complaint to company. So they ask that people's how many minutes or how many time required to solve your complaints. And after using some test or after using some formulas in statistics, okay, so they decide either company solve complaint within a 20 minutes or either company not solve complaint within 20 minutes. Means whenever whatever our problem, so first thing is there are two possibilities. Okay, one is it's happen, or another thing is it's not happen. Okay, so if we talk in a positive manner, that's a null hypothesis, and we talk in a negative manner, that's alternative hypothesis. अशाही प्रकारे आपण म्हणू शकतो. कारण की आपण रिसर्च प्रॉब्लेम कधीही करण्याआधी आपल्याला माहित नसतं की काय प्रॉब्लेम येणार आहे, आणि त्याच्यामुळे आपण काय करतो की जे आपल्याला माहित नाही ते आपण काही प्रेडिक्शन न करता आपण त्याला नल हायपोथेसिस कन्सिडर करतो आणि त्याच्या अल्टरनेटिव्ह थिंग आपण हे आपला अल्टरनेटिव्ह हायपोथेसिस म्हणून कन्सिडर करतो. इन अ रिसर्च सी नियर अबाउट मी एक 30-40 रिसर्च प्रोजेक्ट बघितले असतील डिफरंट डिफरंट, की जे डिफरंट डिफरंट मीन्स स्टॅटिस्टिक्स ॲप्लिकेबल एव्हरीवेअर. सो सम फ्रॉम इकॉनॉमिक्स, सम फ्रॉम सायन्स फील्ड्स, और सम फ्रॉम अगेन जिओग्राफी फील्ड्स. ओके, सो ह्यांच्यात मेजर प्रॉब्लेम हा येतो की दे not formulate hypothesis, or they don't know how formulate proper hypothesis. Okay, so this is a very important part. So this is nothing but what, it's a statements about our research problems. Ki what is before research, before some experimenting, we what we know, that's a null hypothesis, and after experimenting what we get, okay, either it's same from previous things, so our null hypothesis get accepted, or it's different, so our next possibility means our alternative hypothesis get accepted. So this is about null and alternative hypothesis. Okay, there are there are, whenever we talk about hypothesis testing, there are so many steps in hypothesis testing. First, the main step is we identify our problem. Okay, after we identifying our problem, we formulate some objectives, and on the basis of that objective we formulate the hypothesis. Okay, so first is what, understand the problem. After that, formulate the objectives, and then on the basis of that objective, find the formulate the hypothesis. Next step is level of significance, or that we choose the level of significance. Means see, level of significance again is a very simple concept. In statistics, there are two concepts. One is the confidence level, and another one is the level of significance. Confidence level shows key what are the possibility our null hypothesis is true. Confidence level shows what are the possibilities our null hypothesis is true, and level of significance shows what are the possibilities our null hypothesis is false. Means suppose we have a confidence in previous, suppose consider the previous example, this one example, and in this example company have a confidence ki they solve all the complaints within 20 minutes. Okay, so company have a 95% confidence they solve all the complaint within 20 minutes, so their confidence level is 95%. Okay, and 1 minus that 95%, that's a 5%, or 100% minus that 95% is 5%, that's our level of significance, or we may say the error. Okay, so if the problem is company solve that all complaints within 20 minutes, so if company not solve that complaint within 20 minutes, that's an error. Okay, and that error is nothing but what is the probability of happening that error. Probability of happening that error is nothing but our level of significance. Okay, now next is to select test statistics. Means see, there are in statistics there are hundred of tests, and different tests used for the different reason. There are t-test, chi-square, and so many tests, but different tests have some specific reason, or if some specific condition, if that condition is a present, we use that kind of a test. So after choosing level of significance, or after choosing how many percent error we want in our test, so after choosing that, we select the proper test that we require for our analysis. Okay, and that's the next step, is the selection of test or test statistics. Okay, now next is after selecting test, there is individual formula for uh, 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 there is some formula, there's some individual formula for specific test, like t-test have some formula, chi-square have some formula. So using that formula we call as a test statistics. So using that formula we calculate test statistics. Test statistics is nothing but the like some mathematical formula, and that gives some numerical value to us on the basis from our data. Okay, so this is the test statistics. After test statistics, um, next part is the making decision. So see, in the making of decision, again there are two three types. One, uh, we make decision on the basis of table value, and one we make on the decision of p value. I think many of sirs present here, and they are aware about the concept of p values. Okay, so table value is what? Table value is nothing but the one value that we calculated by using level of significance, and there are some statistical tables are present. Okay, if you check, if you search on internet, there some t test statistical table or f test statistical table, you found some tables. Okay, and or आपण त्याला आणखीन काय म्हणू शकतो बेटर मध्ये, some standard values. Okay, so we found some standard values, and uh, and if our that standard value is less than our calculated value that we calculated by using test statistics, so we reject h0, or we make a decision, reject h0 or accept h0, that we decide in first steps ki what is the hypothesis. Okay, and if that standard value is greater than our calculated value, that time we, what we do, we accept h0, means whatever that we assume, whatever we have a 95% confidence that we assume, that's the true things. Okay, so this is about making decision. Now final, after making decision, what is our conclusion? Okay, so in previous example, see in this example, after testing all this kind of things, finally we conclude if the given company solve that complaint within 20 minutes, or the given company solve do not solve that complaint within 20 minutes. So this is our conclusion. Okay, so another one example I want to give here. Suppose if we are doing nothing, and we just take one Parle-G biscuits. Okay, and if the backside of that biscuit packet there is some weight. Okay, so like 80 grams, 60 gram, whatever. Okay, and we, our research problem is now like keep the weight of that Parle-G biscuit is exactly that 60 gram or not. Okay, so what we do, we take few samples of that biscuit packets and we measure the weight, and after measuring that weight we get some mean like 58 grams. Okay, now, and we get some standard deviation value also. So on the basis of that value, we interpret key exactly weight of that biscuit packet is 60 gram or not. Okay, again, this is in this case here, our, what is our null hypothesis? Null hypothesis is weight of that biscuit packet is 60 gram. Okay, and alternative hypothesis is the weight of that packet is not 60 gram. Okay, so this is the hypothesis, and this is another example related to this hypothesis testing. Again, previously I mentioned so many tests. So again, here are some parametric test. What is parametric test? First of all, parametric test is nothing but the, if our data is normally distributed, if our data is normally distributed, that time we use parametric test. How we check the normality, the concept arises. So there are so many techniques to check the normality, but best and very simple techniques is, if we draw the histogram of on our data, or by using our data, if we draw the histogram and we found some bell shape, after drawing histogram or after drawing frequency polygon, I think most of persons or most of students here, I think from BSc third year, so they may know about histogram and frequency polygon. Okay, so if you draw the frequency polygon and that shape of that histogram or shape of that frequency polygon is look like, see this, uh, uh, okay, this is bell shape. Okay, na? So if the shape of that histogram look like this, okay, so that means our data is normal. Okay, again, there are so many statistical tests also, like Shapiro test, Kolmogorov test, but this is the very basic part, so that's why we not go there. Again, Another one thing is box plot. Again, this is one diagram that most of time uh, we use to finding to check out our data is normally distributed or not. So first assumption of parametric test is normally distribution. Again, that there is one theorem in statistics, and that theorem is called central limit theorem. Okay. And those belonging from statistics background, they know these things, but those not belonging, they may not know about these things. So central limit theorem is a very simple in one statement. If our data is very large, means like 100 samples, or we have more than 100 samples, okay, so that time we consider our data as our data is normal. Okay, if we have less sample, then we not consider our data is normal, but we have a large sample. In book, they give, in books they give more than 30, but in some cases we have high dispersion. That time we not get the normality after we have more than 30 samples, but we have a like thousands, like 500, like more than thousands. In that case, we directly consider our data is normal, and we directly use the parametric testing. Means simple, our data is normal, we use parametric testing. Now, t-test. Whenever we do research, these tests are applicable in research. So if we have a questionnaire, uh, so, in 95% times, in 100 cases, 95% cases, we use chi-square test to analyze some results of that on that questionnaire data set. Okay, or that primary data set. Okay, so first of all we discuss step by step some parametric test. But I made one mistake here, because chi-square, uh, we not call chi-square is a parametric test. Okay, so uh, chi-square comes under the non-parametric test, because chi-square, if we have a skewed data, that time we use chi-square. So chi-square test is not parametric test. So but t-test and ANOVA is a parametric test. See, suppose now there are t-test, and t-test we use for the comparison of mean. Okay now, so I'll give one example. See, previous example. Okay, so company solve complete within 20 minutes. Okay, so mu is equal to 20, means company tells us ki we solve your complaint within 20 minutes. So mu is equal to 10, means that company gives some idea, or company, or we call, in statistical language we call as population mean. Okay, means all complaints solved within 20 minutes. Okay, so this is nothing but the population mean. Okay, or the mean that given by company. So we consider that value is a population mean. Now we take some samples, and we ask them how many times required to solve your complaint. So they say 20 minutes, 17 minutes, 15 minutes, and we note down that all things, and finally we calculate sample mean. Now here we compare the sample mean with population mean. Now here we compare the sample mean with population mean. So that time we use t-test, वन सॅम्पल टी टेस्ट. म्हणजे जेव्हा आपल्याला सॅम्पल द्वारे काढलेला मीन हा आपल्याला पॉप्युलेशन द्वारे काढलेल्या मीनला कम्पेअर करायचा असतो, त्या कंडिशन मध्ये आपण वन सॅम्पल टी टेस्ट यूज करतो. नाव अनदर इज थिंक इज इंडिपेंडेंट सॅम्पल टी टेस्ट. नाव सपोज वी हॅव टू सॅम्पल्स फ्रॉम same factor. Suppose we have two liquids, and or sorry, not two liquids, we have two drugs, and we just want to check out the effect of that drugs. Okay, so we give that one drug give to 20 patients, and another drug give to another 20 patients. Okay, and we check out some readings, some numerical readings. Okay, and we want to compare them. Okay, so if either we found that two drugs have a same effect, or some drug have um, higher effect than another drug, and or like alternative hypothesis, like ki two drugs have not have a same effect. Okay, so yes sir. Okay, so this type of condition here we use independent sample t-test. Now peer sample. See, peer sample, here we have a related data. Suppose In simple case, I'll give one more example. We have a data of 50 uh, old age peoples. The peoples have blood pressure, means they have higher blood pressure, or some problem related to blood pressure. 50, we take the samples of 50 peoples, and we give yoga training to that 50 peoples. Okay, and after 1 month, we calculated, again we calculate the blood pressure of that 50 peoples. Okay, so if previous we have a data of same 50 peoples, we use some treatment, and after that treatment we again check out the, again we take the data from same sample. So in that case, we want to check if our our that treatment is impactful or not, our treatment is impactful or not. In that case, we use PRT test, because we take the some samples, so 50 samples, we give some treatment. After that treatment, again we take same 50 samples, and we take same 50 samples data, and we just want to check here our treatment is impactful or not. Okay, in this condition, we use peer test, means we have correlated data, we have same set of same peoples previously and afterly, or we have previous after data. So in that scenario, but continuous data, here we require continuous data, continuous. If we have categorical data, then we not use peer test. Okay, if we have continuous data, and that data is really before after kind of a data, or that data is related to each other, then that case uh, we use PRT test. Now another, our next is one way ANOVA. Okay, so one way ANOVA, again very simple. See, if we want to compare two samples mean together, if we want to compare two samples mean together, that time we use T test. Okay, but we want to compare more than two, means we have three samples. Okay, so it, yeah, that time also we use T test to compare first second, to compare first third, to compare second third. So there are, we need to use three T tests there. Okay, but when we want to compare more than three samples at a time, or three samples mean at a time, in that condition, whenever we want to compare the three, more than three samples mean at a time, in that condition we use we use one sorry, in that case we use one way ANOVA. Okay, and now suppose we have two different samples. Okay, means a sample, some factor A have some levels like low, high, medium, and factor B have some levels low, high, medium. Okay, and see the, where we have two factors, and two factors have a three levels. Okay, so in that, in this case, we use two-way ANOVA, because we want at a time we want to compare the levels of two different samples. Okay, so that time we use two-way ANOVA. The two-way ANOVA best example in agriculture fields. Okay, so in agriculture field, see, we have a different kinds of pesticides, and we again we have a different kinds of uh, irrigation आहे म्हणू शकतो आपण त्याला. पण we have different kinds of ureas, or आपण ते different types of खत म्हणू आपण त्यांना, मला स्पेसिफिक नाव नाही माहिती. ओके, सो आपल्याला जर त्याचा दोन्हीचाही ऍट अ टाइम आपल्या पिकावर काय इम्पॅक्ट होतोय हे चेक करायचं असेल ना, तर आपण त्या सिनेरिओ मध्ये आपण टू वे ANOVA यूज करू शकतो. ओके, सो मीन्स फर्स्ट फॅक्टर इज अ पेस्टिसाइड, and second factor is a fertilizer. Okay, and we have two factor at a time, both factor have more than two levels. Okay, so in that scenario, if we want to compare the mean, then in that case we use the two-way ANOVA there. Okay, again it's a very simple. Now next is a chi-square test. Okay, it's a part of, and it's a most popular test. Chi-square test is some person call it as a chi-square test, but it's not a chi, it's a chi-square test. And there are again two types of chi-square test. So First type of chi-square test for goodness of fit, and second type is a chi-square test for independency of attributes. Now I'll give one simple example, then everyone get about how chi-square test is working. See, now these days, many old age people have a joint pain. Okay, one research problem came from medical college, from medical college Nashik, and again the research problem very simple. Just they want to check if temperature is a decreases, then joint pain is a increases or not. Okay, so everybody know about this, but they take a data, collect data regarding with this problem, and they use chi-square, and it's very good thing. And see, very simple. If uh, we take the temperature, one factor is the temperature. If suppose we ask someone to is feel very colder or not, okay, yes or no. Okay, so means if colder, yes or no. And another question is like you have a joint pain. Okay, so first is what here chi-square. See, factor A, colder or not, okay, is another thing. Factor B, you have a joint pain on of colder, is another thing. But see, we want to check here if uh, colder the temperature, then most people feel joint pain. Okay, this kind of problem we have. Okay, so we collect the data of 100 samples, and we found that some people feel colder and they have joint pain. Okay, those are very young peoples, they not feel colder and they not have a joint pain. Okay, some people is like they have some injury, so they may not feel colder but they have a joint pain. And some people are like ki they feel colder but they do not have a joint pain. Okay, these are the possibilities, and we want to check the association between if there is some cold condition, okay, the people feels joint pain or not. Okay, so in this type of scenario we use chi-square test. Okay, so means whenever we want to check the association between two types of categorical variable, whenever we want to check the association between two types of categorical variable, that time we use chi-square test. Very simple. Okay, again, I not mention here. Suppose as categorical data, we have some categorical data, and we just but data is like in the form of after before. Okay, so we have categorical data, but that categorical data is correlated. We have categorical data, that categorical data is correlated. In that time, there we use McNamara test to check there is association or not between pre and post. So very simple. See, in t-test, one sample, independent sample, paired sample, one way ANOVA, two way ANOVA. And in chi-square test, what is the independence of attribute, that we discuss. Okay, now next is non-parametric test. Suppose we have some small sample size, and our data is not normally distributed. Here is no assumptions, means what our data is normal, not normal distributed. We have a numerical data, but our data is not normally distributed. Ma'am, can I take 1 minute?
Yes, sir. Yes.
Okay, ma'am, thank you. Okay, so non-parametric testing. See, if our data is not normally distributed, in that scenario we use non-parametric testing. Um, so see, if we want to compare two groups, okay, and we our data is normally distributed, then that time our mean shows central tendency. Okay, so if our mean shows central tendency, when mean shows central tendency, our data is normally distributed, then mean shows central tendency, and by using t-test we compare the mean. Okay, If some persons have some questions, then they please ask after completion of this presentation. uh, uh, See, first thing I'll explain one more time. If our data is normally distributed, then uh, we calculate the mean. If our data is not normally distributed, that time mean does not show center value, so that time median shows center value. But our data is normally distributed, then mean shows center value. Then for the comparison of mean, we use t-test. Okay. Now, if our data is not normally distributed, here I mentioned there is no assumptions, that time mean does not show central tendency, that time median shows central tendency. So we compare the median by using Mann-Whitney u-test. Okay, and it's non-parametric, alternative non-parametric test for the independent sample t-test that we see here. In previous slide we discussed about independent sample test, but our data is not normally distributed. That time alternative non-parametric test is a Mann-Whitney test. Okay. Now next is the Wilcoxon sign rank test. So in Wilcoxon sign rank test, see, if our data is correlated, means like peer t test. Okay, so Mann-Whitney U test is the alternative form of independent sample t test. So similarly, Wilcoxon sign rank test is an alternative form. Wilcoxon sign rank test is an alternative form of independent sample t-test, or we may say peer sample t-test. Means peers, if our data is not normally distributed and we have after before data, or we have some data that correlated to each other, in that scenario, we want to check out there is significant difference uh, in median of that correlated data. So that time we use Wilcoxon sign rank test. Now see, in Mann-Whitney test we compare the two medians. Okay, but sometimes we want to compare the more than two medians. Sometimes we want to compare the more than two medians. So that scenario we use Kruskal-Wallis test. Okay, see, similar kind of here. See, in a previous slide. Okay, so one sample t-test, independent sample t-test. Okay, means we have population and sample, then one sample. We have a two independent sample, when we want to compare their mean, independent sample, but we have a three samples in previous case, but our data is normally distributed, so we use ANOVA. But in this condition our data is not normally distributed, so but we want to compare the more than two samples, or more than three samples. In that scenario we use Kruskal-Wallis test. Okay, again there is, I mentioned one more test, two sample ANOVA previously. So there is also one alternative test for true sample ANOVA, that's a Friedman test, but that's a very difficult to understand for non-statistician. That's why I'll not mention Friedman test here. Okay, so this is about non-parametric and parametric testing. So now correlation. Okay, so there are again so many types of tests. So, but due to sufficient amount of insufficient amount of time, so I'll not include that all test in our present in my presentation. So so next is correlation. Again, correlation is everyone knows about correlation, because correlation is used in so many times, or uh, in we when we are in 10th, means the third year students, when they pursue 10th and or 12th, that time they find there is one in 12th chapter of mathematics, there is one term correlation. Okay, again the very simple term correlation measure the statistical relationship between टू कंटिन्युअस व्हेरिएबल्स. ओके, जेव्हा आपल्याकडे दोन कंटिन्युअस व्हेरिएबल असतील, त्या कंटिन्युअस व्हेरिएबल्स मधले त्याच्यात काही स्टॅटिस्टिकल रिलेशन आहे का, मीन्स इफ value of one variable is increases, value of another variable is increases or not. If value of another variable is decreases, then value of another variable is increases or not. If value of another variable is decreases, value of uh, uh, other variable is decreases or not. Means we have two variables, and which we just want to check out the values of one variable is impacting the on values of another variable or not. Okay, very simple. So value of one variable is impacting value of another variable is not. uh, so for that purpose we use correlation. Okay, and correlation gives strength of relations between that two variables. See, again, it's a linear relationship. If linear means if a increase from 2 by 2, b also increase by 2 or 3. If a is increase means if एक म्हणजे ए मध्ये जर एक न बदल झाला तर बी मध्ये दोन न बदल होतोय. मग ए मध्ये दोन न बदल झाला तर बी मध्ये चार न बदल व्हायला पाहिजे. ए मध्ये तीन न बदल झाला तर बी मध्ये सहाने बदल व्हायला पाहिजे. म्हणजे दोनचा डिफरन्स आहे. तर या प्रकारचं जे रिलेशन असतं ना त्याला आपण लिनियर रिलेशन म्हणतो. म्हणजे ज्या अमाऊंट मध्ये ए वाढतोय त्याच अमाऊंट मध्ये बी वाढला पाहिजे. सो दॅट काइंड ऑफ रिलेशन्स वी कॉल ॲज अ लिनियर रिलेशन. ओके, सो whenever we want to find strength of linear relation in linear relationships, that time we use correlation. So again, correlation using correlation denoted by using r. R is called the correlation coefficient, and correlation coefficient value is lies between -1 to 1. Okay, so suppose if we calculate the correlation value by using we have a correlation formula. Okay, so by that formula we calculate the value of r, and if our value of r is approximately 1 or near to 1, that's indicate perfect positive correlations. Perfect positive correlation means like if value of one variable is increases, value of another variable is also increases, but by same, like if a increases by 2, then b increases by 4. If a increases by 3, then b increases by 6. Means same proportion असं वाढत असेल तर तेव्हा ते perfect positive correlation असतं. Now next, if value of one variable is increases and value of another variable is decreases, value of one variable is increases, value of another variable is decreases, then the correlation between them or r is between them is -1. So that's indicate परफेक्ट निगेटिव्ह कोरिलेशन. म्हणजेच एका व्हेरिएबलची व्हॅल्यू वाढत जाते, दुसऱ्या व्हेरिएबलची व्हॅल्यू कमी होत आहे. एखादी वाढत जात आहे, दुसऱ्याची कमी होत आहे. तर ह्या प्रकारचं जे आहे का रिलेशन, त्याला आपण म्हणू शकतो परफेक्ट निगेटिव्ह कोरिलेशन. ओके, तर त्याची व्हॅल्यू आर ची व्हॅल्यू -1 आली सर, आणि सपोज आर ची व्हॅल्यू 0 आली. ओके, सो दॅट्स इंडिकेट नो लिनियरशिप बिटवीन देम. म्हणजे जर तुमच्या आर ची व्हॅल्यू 0 होते तर त्याचे तुम्हाला लिनियर रिलेशनशिप भेटणार नाही. Okay, but we found in many times we found that if we calculate the correlation, our value comes like 0.3, 0.2, 0.5. Okay, so that's nothing but the there is very low correlation present. See, correlation formula, if you put some numerical values on correlation formula, that formula does not give perfectly 0, but that formula gives like 0, 20%, 30%. Okay, so that means our given two variables have a very low correlation. So then how we check out ki our correlation is significant or not? So again, there is one test in a statistics called the correlation t-test. Okay, so by using correlation t-test, we calculated our correlation is significant or not. Okay, next is interpretation of correlation. If our correlation value is lies between 0 to 1, then we called as there is perfect positive correlation, or there is if our correlation value lies between 0 to 1, then we call that positive correlation. If our correlation value lies between 0 to -1, okay, 0 to 1 positive correlation, 0 to -1 it's a negative correlation, and our correlation value is r is nothing but the 0, then that's indicate uh, no correlation there. Now again a little bit about regression analysis. See again, correlation. In a correlation, see, I mentioned here, in correlation just show the strength. ओके, मीन्स एक वाढला तर दुसरा वाढतोय की नाही, हा, एक कमी झाला तर दुसरा कमी होतोय की नाही. कोरिलेशन जस्ट शो द स्ट्रेंथ. ओके, बट by using regression analysis, it's a part of one paper in statistics, or is a one uh, part of statistical theory is a regression analysis. By using regression analysis, we predict. Okay, suppose we want to predict, suppose like if a changes from 20, what are the change take place in a b. ओके, म्हणजे ए न जर 20 मध्ये बदल झाला तर बी मध्ये कितीनं बदल होतोय हे आपल्याला बघायचं असेल. हा, त्याच्यात कोरिलेशन आहेच, कोरिलेशन लागतंच, कारण की कोरिलेशन, ज्यात कोरिलेशन असेल तरच आपण रिग्रेशन कडे जातो. ओके, सो ए मध्ये बदल झालाय तर बी मध्ये कितीनं, ए मध्ये जर 20 न बदल झाला तर बी मध्ये कितीनं बदल होईल. ओके, सो वी वॉन्ट हिअर वी ट्राय टू प्रेडिक्ट. Okay, here we try to predict if a changes by here I mentioned not a, here I mentioned x is a independent variable, here y is a dependent variable. Okay, here is x is independent variable, y is dependent variable. If x changes by 20, how much change take place in a y. Okay, so if we have a this kind of a data, that time we use uh, regression analysis. Sorry, we want to predict this kind of data, that time we use regression analysis. Okay, so here see, this is the, there are again so many types in a regression. See, there are simple linear regression, multiple linear regression, polynomial regression, uh, uh, again stepwise regression, robust regression, lasso regression, so many types. But in general, we use two types of regression. One is simple linear regression and multiple linear regression. So in simple linear regression, this x is nothing but the independent variable, this y is nothing but the dependent variable, and this alpha plus beta is nothing but the alpha is the slope and beta is the intercept, and one term is remaining there, that's e, that's error. Okay, so if we see this equation is look like a straight line equation, like y is equal to mx plus c. Okay, so yeah, in that, y is equal to mx plus c, in that equation also y, m indicating slope and c indicating intercept. Same here, alpha indicating intercept and beta indicating slope. So what is slope, what is the interpretation of beta? Simple interpretation of beta is key, when uh, uh, unit change take place in a when unit change take place in a x, how much change take place in a y. म्हणजे जर एक एक्स मध्ये एक न बदल झाला तर वाय मध्ये किती न बदल होतो. ओके, सो दिस इज व्हेन वी हॅव वन इंडिपेंडेंट व्हेरिएबल अँड वन डिपेंडेंट व्हेरिएबल, दॅट टाइम वी यूज सिंपल लिनियर रिग्रेशन, and here beta indicating slope and alpha indicating intercept. Now same for multiple linear regression, uh, when we have a more than one independent variable, like 2 3 or some n values of independent variable and one dependent variable, in that case we use multiple linear regression. Means, by example, suppose my annual income is a independent is a dependent variable, and now there are so many factors that affecting my annual income, like salaries, like income from some farms, like again income from some other work. Okay, so these are the parameters that affecting my final income or final year income. Okay, so that's why here each individual is an independent variable and my y is dependent variable. Okay, so here y is dependent variable, x is a exploratory variable or independent variable, beta naught is the intercept, and beta I or beta p is a slope coefficient. Means, see, when change in x1, when unit change in x1, how much amount of change take place in a y1. Okay, so that's indicating by beta 1. When unit change in x2, how much amount of change take place in a yi or yi, that's indicated by beta 2. When unit change in a xip, how much amount of change take place in a yi, that indicate by using beta p. Okay, so and finally e is a error term. Okay, so ma'am, thank you. This is about today. If somebody have a
Question. Now the presentation is open for the discussions. You have any
yes,
questions
some
from
people
the
have question.
participant side? Now the presentation open for the discussion.
Sir, Zafar sir's hand is raised.
Hello, ma'am.
Zapar sir, ask the question.
Okay, I'll check out. Sir.
Anerao sir, there is one question in comment box.
Okay, ma'am. Because me mobile mode ma'am. Please give me 1 minute.
Question is how this statistical treatment is helpful in organic synthesis. Sangeeta Pawar ma'am.
Okay, ma'am. Eco हो गई. हाँ मैम बोलो.
How this statistical treatment is helpful in organic synthesis.
Okay. So see, if you have some, because, I don't know some cases. In that cases, we use this technique. Okay, if you tell me some problem, then I'll explain related to that problem also. See, if you want, ma'am, इको होतोय का?
इको होतोय सर.
हाँ, तेच. See, if you want to come.
Excuse me, sir. Please switch off the mic of the another device.
Yes, sir. Now, okay?
Okay, sir.
Okay. Yes, ma'am. Yes, Zafar Hassan sir have one question. What is difference between polynomial and linear curve? See, sir, when we have a linear relationship between two variables, see, if one is increases, another is increases linearly. Okay, so that time there we use linear curve. Means if two variables have a linear relationship. Okay, there is echo. Ma'am, is it okay now?
Okay.
If two variables have a linear relationship, okay, so that time we use linear curve, or we in statistics we not called as linear curve, we called as a linear regression. Okay, so means one variable is increases, another variable is also increases. Okay, so that time we have linear relationship, so that time we use linear curve. Now second is a polynomial curve. See, when our data not have a linear relationship, okay, so that time suppose our data have some u-shaped relation. We plot the data and we find some u-shape, okay, relation. Okay, so that time, in that case, what we do, we just take square of our independent variable and we add that uh, variable in our model. Our models look like y is equal to beta naught x1 plus x1 square. Okay, so that time our same model get converted into the polynomial regression. Okay, means ki suppose we have a linear relationship in our data, then that time we use uh, linear regression, and we have curvilinear relationship on our data, so that time we use non-linear we use polynomial regression there, okay, or polynomial curve there. So if again if our data follows polynomial, if our data is suitable for a polynomial regression, and if you calculate the correlation of that data, okay, so our correlation is approximately 0.4 or 0.3, means is insignificant. So that's also we find, we check out our spread of data is polynomial or not. How to interpret polynomial curve? Okay, so sir, on the basis of their coefficient, so there are whenever we use regression analysis, there are like beta 1, beta 2, and beta naught. Okay, so by using beta 1 and beta 2, there is, on the basis of beta 1 and beta 2 values, we get some RMS there. That's a root mean sum of square value. If root mean sum of square value is a lower, then our polynomial curve is a better, or polynomial regression is a better. Okay, so yes, by using root mean sum of squares, or again there is R square also, by using R square. If R square value is very good, then our model is good fitted.
Any question? Joshi sir.
Okay, Shengi sir, continue please.
Thank you, Aashish sir, for a valuable lecture on data analysis. It is also helpful for
Sir, I think there is one question.
yes.
No, ma'am. If you do synthesis, if there is some numerical value is present, or there is some categorical value is present, if you have some observation or you have some readings, okay, so that time we do statistical analysis. But it's totally depend on.
Sir, this is echo is there. I can't hear clearly.
Okay. Is it okay now?
Okay.
Yes, sir.
Ma'am, if it's depend on your data, if your data is present in a categorical form, that time also we use statistical test there. Okay, but if your data, we convert your data into in numeric form, and after that we use test. So no problem if you have categorical data, because ma'am I'm not aware about organic synthesis, so I'm not able
Yes,
to give answer. But if you give me the problem, or if you show me the data, I will definitely explain you how we use statistical test there.
Okay, sir. Okay, sir. Thank you.
Yes. And I just want to mention one thing. If anyone from today's lecture have some problem, they send me data. I will discuss with you how we use statistical test there. Okay, ma'am.
Now may I conclude?
Shengi sir.
Joshi sir.
Sir, yes, let Dr. Shen introduce you, sir.
Chairman of today's session is Dr.
Shengi sir,
Sawarkar.
echo येतोय. Unmute करून पुन्हा mute करा बरं. Echo येतोय तुमचा.
तुमच्या शेजारी कुठेतरी बसला असेल ते सर, त्यांना तुम्ही जरा दूर जाता. ओके सर. Hello, am I audible?
Yes, yes, sir, yes.
Chairman of today's session is Dr. Sunil Shankarwat sir. He is a professor and head of Department of Chemistry, Dr. Babasaheb Ambedkar University, Chhatrapati Sambhajinagar. He is a good researcher and well-known teacher. He published 70 research papers in international journals. I request to Dr. Shankarwat sir deliver its chairman address.
Thank you, sir. Thank you. Now, first of all, I would like to thanks to organizing committee member of National Workshop on recent trends in research methodology for inviting me as a chairperson for this session. I am very much thankful to Dr. Aashish Anerao for giving the informative talk on techniques used for data analysis. Sir has explained the steps of research process, basic concept of statistics, collections, organizations, analysis, interpretation, and presentation. Sir has also explained the types of data, qualitative and quantitative data. Sir has also explained the measurement of central tendency and dispersions like the mean, median, mode, range, and standard deviations. Sir has also explained the hypothesis testing and different steps in hypothesis testing. Sir has also explained the parametric test, non-parametric test, correlations, positive and negative correlation, linear relationships, and interpretations of correlation. Last, sir is also explained the regressions analysis. Now, this data analysis techniques is very useful to the student, researcher, and all the teaching staff, all the teaching participants. So, on behalf of Department of Chemistry, Sawarkar Mahavidyalaya Bid, and analytical chemistry teachers and researchers associations are thankful to you, sir. Thank you very much. Thank you, sir.
Thank you very much, sir.
Thank you.
Today is the last day for the national workshop on recent trends in research methodology.
Echo, sir.
First day,
Echo.
Professor Dr. Arif Pathan delivered the lecture on writing a research project and research papers. Am I audible, ma'am?
Yes, sir. Yes.
Second day, Dr. Professor Munde sir delivered the lecture on importance of literature survey and digital web resource and research search engines. And today, Dr. Aashish sir delivered the lecture on techniques for data analysis. Sir, near about this workshop is a huge response. Near about 350 registration are done. So, vote of thanks. Sir, can I give to vote of thanks?
Yes, sir. Yes.
I would like to thank to Dr. Priti Pohekar ma'am, Principal Swatantraveer Sawarkar Mahavidyalaya Bid, giving opportunity to organize such a national workshop on recent trends in research methodology. And I would like to also thank Dr. Professor Mazhar Farooqi sir for the chairman of the first day session. I would like to also thank Dr. C.S. Patil ma'am, chairman of ACTRA, and I would like to also thank Vice Principal Bahegawankar sir, स्वातंत्र्यवीर सावरकर महाविद्यालय बीड, and Dr. Dheri sir, Vice Principal of Swatantraveer Savarkar Mahavidyalaya Beed. I would also like to thank Dr. Arif Patan sir, the speaker of first day session. He delivered the lecture on writing research project and research papers. I would like to also thank to Dr. Professor Tukaram Munde sir. He delivered the lecture on importance of literature surveys, digital web resonance and search engines. And I would like to also thank Aashish sir for today's lecture. And finally, I would like to also thank for all the participants who joined directly on the meet. Thank you, sir. Thank you, all of you.
We are also thankful for Professor Dr. Sunil Shankarwar sir, head of the department, University campus, Dr. BAMU Chhatrapati Sambhajinagar.
Thank you, sir. Thank you.
Thank you one and all for participating this workshop. Every participant will get the e-certificate after filling the feedback.
Anerao sir.
Yes, ma'am.
छान झालं.
थँक यू मॅम. इनसफिशियंट टाइम बिकॉज स्टॅटिस्टिक्स आपण एक्सप्लेन करू शकत नाही मॅम विदिन आवर मध्ये.
नाही, खूप सोपं करून नाही केलंस तू.
आशिष सर, अनेराव सर.
प्राऊड आयल म्हणाय.
हॅलो.
छान झालं सर.
प्राऊड आयल म्हणाय.
येस सर.
हा, छान झालं.
थँक यू सर.
बरीच सर्व्हिस पास, बरेच एक्सपिरियन्स 20-25 वर्षाचा घेतल्यानंतर पर्सन कॅन गिव्ह सच नाईस टॉक दॅट यू हॅव डिलिव्हर्ड.
थँक यू सर.
अरे तू एकदा दाखवायचं असतं ना चेहरा आम्हाला.
अरे मॅम शुअर ते इको होतो त्याच्यामुळे लॅपटॉपचा कॅमेरा ओपन होत नाहीये आणि ते इको होतो म्हणून मी बंदच करून ठेवलाय. मॅम शुअर मी काय करतो,
स्क्रीनशॉट घेतला असता एक तुझा.
हा मॅम मी काय करतो, मी मोबाईलवरून जॉईन करतो.
छान झालं सर.
हॅलो.
हा मॅम.
आलास का?
हो मॅम आलं.
शेंडगे सर,
हा सर.
चांगलं झालं बरं का अँकरिंग.
थँक्यू सर.
अँकरिंग, प्रास्ताविक सगळं चांगलं झालं.
तुमच्या
नाही
सपोर्ट मुळे झालं
तुम्ही तयारच होता, पण उगीच तुम्ही हे म्हणत होता जमेल का नाही वगैरे. एकदम छान केलंय तुम्ही.
ओके, थँक्यू सर.
सर.
हॅलो.
हा सर, ऑडिबल आहे. हा सर.
हा बोल.
जर पॉसिबल असेल तर सर, कारण की स्टॅटिस्टिक्स विदिन आवर इट्स नॉट पॉसिबल थिंग ना. सो इफ पॉसिबल, आणि कारण की आता सगळ्यांना स्टॅटिस्टिकल टेक्निक्स यूज करावं लागतात रिसर्चमध्ये, तर सर आपण त्याला डिवाइड करून एक चांगल्या प्रकारे की जे आणखीन हे होत असेल की पॉसिबल असेल तर आपण सर करू शकतो सर.
आपला जो आता मी जो सिलेबस पाठवला तो कव्हर झाला नाही त्यामध्ये.
सर हाफ कव्हर झाला.
हाफ कव्हर नाही, शक्य नाही एवढ्या वेळेमध्ये सगळं टोटल घेऊन.
हो आणि सर म्हणजे ते की क्रायटेरिया कसं की सर बेसिक पासूनच जावं लागेल ना, कारण की आयडिया नसेल स्टार्ट